I would like to introduce Simon Keates of Thales, who will conclude this conference by letting us know how to make the world a more happier through being more secure and having trust also in the IoT stuff, which will affect all of us, or is affecting all of us already, but much more in the future. So, go ahead, Simon.
Thank you, Thomas. Hey, so good afternoon, everyone. As Thomas said, I'm Simon Keates. I work for Thales Security. It's a real pleasure to be here, so thank you very much to PrimeKey for having me here. But I feel a little bit inadequate following some of the audience or the presenters today, like David, like Cindy, where real practitioners of IT security. I'm coming at it from the vendor side, so I'm sure. Again, I'll have the obligatory who was Thales Security slide, and apparently we need to apologize for this. So my apologies. And I'm sure a lot of you either know of us or our competitors in terms of the HSM market. But we've been doing this for a long time. Our legacy, our history comes from the credit card payment side of things, but more and more we're getting involved in other kinds of projects, and IoT is just another one of these I think evolutions of our security posture and where we get involved. One thing I did want to point out is our technology partnership program, the ASAP program, of which PrimeKey is a very important partner for us. There are 130 other vendors here. They're not all PKI related. There might be people like Nutanix or F5 or Cisco, where we are strongly integrated with them as part of this partnership program. So, wanted to talk about the IoT, but specifically about trust. And it's great kind of following a lot of the presentations from yesterday and today, thinking about trust and about happiness and what that means. And from the Thales point of view, and specifically from how we can help to implement some of those processes and some of that procedure to establish trust within these deployments. So if we take a bit of a glimpse into the future and think about what IoT might mean, and I'll say it again probably many times, it's not my shiny smartwatch or light bulbs and things like that. When we think about IoT, it's very much about smart cities, industrial IoT, critical infrastructure. So where might connected devices, embedded systems start to influence our lives and have an impact on how we do business, how we interact with systems, what data is collected, and how they themselves might think about monetizing us as citizens and as consumers. So, thinking of our vision of a city in the future where you've got smart living, smart transport, leisure, energy, working, navigating through the system, how the city interacts with us, how we interact with that city. There are many elements here, and as we connect, we'll see more areas where risk will become abundant, where attack vectors will start to increase, where we need to start implementing trustworthy trustworthy systems to protect that data, to protect those communications and establish integrity within these systems. But I think we need to go a little bit back in time to start thinking about some of the lessons learned and some of the predictions that were made only a few years ago in terms of what worries we have within what we're now seeing as the IoT. And so we don't need to go quite that far back. We're not going to talk about the communicators or Jules Verne, but just a few years back, 2015, where we were working with Gartner, and a lot of predictions came out talking about this year. So this is an eye chart, and it's horrible, but pointing out some specific things here. So thinking back in 2015, predicting in 2018 that a lot of our critical infrastructure will be incumbent on IoT authentication methods, for example. More than 50% of the global authentication vendors will deliver a product roadmap for IoT authentication. We're seeing this trend that IoT is more and more part of people's roadmap, part of something that they're thinking of. And I think this point here, that IoT architecture will unleash an era of inexpensive surveillance. We can have devices all over our environment, what we interact with on a daily basis, what we use within organizations, interacting with us, but collecting data the whole time. And we need to be careful of that from a consumer point of view, but we might also think about ways that we can benefit from that as vendors of systems. And of course, thinking about what this means in terms of size of business, trillions of dollars worth of spend within only a couple of years' time. Thinking in terms of risks and problems that we might start to see as a result, we rely on our friend Professor Anderson at Cambridge University, sometimes friend, sometimes enemy. He's not a big fan of HSMs, I don't think, but he studies these systems a lot, and some of his predictions are, thinking about how as devices become smarter, they might become less loyal. And once we put software in everything, what could go wrong? I saw a quote, I think it was on Twitter or something like this similar, but just because we can connect a system to the internet doesn't necessarily mean that we should. Thermostats or light bulbs, like maybe they make sense, but why do I need to connect my kettle or my coffee machine to the internet? Does it really add value? Does it make me happier? And so, as he says, thinking about as devices become less loyal, what kind of business models might make them a bit, find ways to exploit us, or in some cases, perhaps just be downright dishonest. And I'll talk about a tractor vendor, I believe, what I believe to be the story in a little while. So staying in the past, thinking about ways that we've helped to solve problems in terms of counterfeiting, device authentication. We've been working on IoT systems since 2009. This was our first case study when it came to digital birth certificates. And this was before the IoT was called the IoT. And so I'm sure many of us have interacted with these systems, Polycom desk phones for running conference calls and calls from offices. Every single one of these devices is injected with a certificate and a key at the point of manufacture. So a digital birth certificate generated in their factories in an environment that is untrusted, but is done in a way that allows them to minimize the effects of counterfeit, and also to allow the devices to successfully to authenticate to the network, to prove that they're valid devices, but also to assist with the integrity of the data coming out of that device, so that they can implement billing systems within the organizations better. We'll talk about a little bit of the detail in this in a second. But as I said, the keys are injected into the device at the time of manufacture with a trusted process using our enclave technology called CodeSafe, but Utamako has the same thing. I think Gemelto has the same, where there is a programmable layer within the HSMs that you can implement business processes or business procedures in a way that is much more difficult to deviate from. So if you have a software-based process, administrators can be compromised. Perhaps they can be turned malicious because they're disgruntled, something like this. They might have an attacker might elevate privilege to become that administrator. So it's not necessarily about an inside attack, but once an administrator is compromised, software systems themselves can be compromised to do things that weren't intended. So if I set up my system that says I only want to generate 10,000 certificates, I can get into the config, I can change it somehow, and I can double that number. I can say that you can generate certificates for a different MAC address range or something like that. But if you can embed that logic inside an HSM that has dual control or smart card authentication, then that's a hard piece of configuration to try and adjust. And if you have dual control implemented, then you need to collude between multiple parties or attack multiple parties to try and get to that configuration level. Lots of professional services here because this was brand new for us. So we developed the solution alongside Polycom to try and solve problems with them. But we've done many deployments of this nature since then. So a lot of set-top boxes, typically the likes that have day-release movies on them. So it's not your €15 Roku box for watching Netflix. It's a €10,000 box that you can use to watch the latest release of, I don't know, Iron Man on the day that it comes out. And this is, the likes of movie stars and footballers, where they have these devices in their home basements, mini cinema systems. So the devices are deployed in exactly the same way, but it allows for trust to send the movies to those devices in a way that stops them from being copied and shared around. So what does this look like? I know it's a bit of a chart you can't really see, but effectively what happens is Polycom in this instance has delegated their manufacturing, their factory to a third-party plant in the Far East somewhere in an environment that is untrusted. And I think we see this time and again that really a lot of these factories will try and find ways to bypass any processes to produce counterfeit devices so that they can sell them on a gray market or a complete black market. And so by working with Polycom, we introduced this scheme whereby we produce a permission to manufacture statement, if you like. And this is done within a trusted environment, within the United States, within environment controlled by Polycom themselves. And this permission to manufacture is then supplied to the contract manufacturer, and an effective tunnel is set up between the head office in the US and the factory plant in the Far East somewhere. So this tunnel basically allows for the secure transport of certificates and of instructions into another secure repository that is then used to follow those business processes or business rules in the issuance of certificates. And as with HSMs, if any element of this environment is compromised in any way, the attackers get nothing. Things are erased. So all of the instructions and the keys are in the HSM. Everything's encrypted. And you need multi-factor to activate the system, right? So there are a lot of processes implemented within the HSMs themselves so that you can't bypass these through a software stack. So coming back then to where we are and thinking about what the problem is and how we can help. Think about different ways of using this. I think we've seen slides like this time and again where the problem is too big to solve alone. We have millions or billions of connected devices and embedded systems, billions of dollars being spent and data being generated. We've heard about regulation a lot over the last couple of days, not least GDPR and things like EIDAS, but POPI in South Africa and HIPAA in the US. So regulation around the world controlling the way that our data is used, new regulations and new standards coming on board to influence how the IoT works, for example. And so lots of information, lots of data, lots of regulations, and also lots of attacks. And we need to think about new ways of protecting our systems against those attacks while remaining in line with the regulations. And I think we know this really, but I think digital identities are really the first fundamental step here. So how do I know that the device that I'm speaking to is genuinely that device that I've provisioned that's out there in the field? And so I did have the picture, that on the internet no one knows you're a dog, but apparently that's a trademarked image, so you can't use it. But there is this Creative Commons image that, on the internet no one knows you're a dishwasher. But some of the challenges I think that what we come across within PKI environments, within environments that you're familiar with, is how do you go through these typical steps, but with devices where you're talking about not maybe hundreds or thousands of users or of endpoints, but tens of thousands or hundreds of thousands of endpoints, and how do you have some control over that in terms of enrollment and registration, but revocation? And is revocation really a valid thing that we need to continue to think about? How do we worry about identity theft and fraud, and the integrity and usability of those credentials? But I think, as well, interestingly, how do we deal with portability? What happens with aftermarket sales? So I have my dishwasher in my house and I sell it on to somebody else. How do we deal with that at the back end? So do I roll my identity? What do I do with that? And as well, these identities could potentially last years, if not decades. What happens if this is a street lamp, or what happens if this is a pylon out in the middle of nowhere? And we need to think about designing systems that are agile, as we've heard about in the past, where they might last decades or hundreds of years. So what does this look like for us? I keep talking about dishwashers and light bulbs because I think it's an easy model, but for us this isn't really the focus. So fridges, toasters, washing machines, these aren't really where we need to be putting in effort. It's rather in smart factories, predictive maintenance, autonomous vehicles, drones, defense, military, critical infrastructure where there is greater amounts of risk. But also the service economy. So thinking about ways that we can design systems or products whereby we can bill users on on a per-use basis. So Rolls-Royce, for example, thinking about doing power by the hour type solutions. Whether good or bad for us yet, I'm not too sure. As I said, we've been working on solutions like this for a long time. Like Polycom was done almost a decade ago, but more and more we're seeing projects like this, working with Samsung Arctic, where they have chipsets or boards where our keys and our HSMs are used to inject keys and certificates at the point of manufacture. And then thinking about how to mitigate against certain threats using things like code signing for the firmware and gray market defenses. And so I think going forward then, we need to consider solutions for device credentialing more carefully. So a bit of a kind of workflow here about how identity might be provisioned through a system, how HSMs might be used within this infrastructure to try and secure some of that. And we've, as I keep saying, we've been working with companies to really try and help ensure that the identity is birthed in the strongest way possible. I think the biggest risk for me is if I can compromise that birthing procedure, I really undermine the entire system that's implemented to secure that. So I remember, I don't know, guys in the 90s or so getting software downloads that had keys that we needed to input to activate that software. And so often the keys, the private keys would have been leaked, and you could get a download of a website to generate your own activation key. So we don't want to be in a position like that where someone could come along, grab the private keys and implement systems that would allow the issuance of certificates for devices to appear as if they are valid on your network. And we've been working with PrimeKey on solutions like this, and we have a number of telco projects that we've been involved in to design systems where we can enhance that birthing. There's a lot of standards here, and I know as an organization, Thales is very much involved, and we're in part of the heart of these design decisions, working with the Linux Foundation EdgeX Foundry, the Industrial Internet Consortium, and other bodies, particularly in automotive, where I think because there is a high risk, there is a strong understanding that secure systems need to be designed from the beginning. And so, again, Thales is very much part of this. So I wanted to think about a little bit what this might look like out in the field, and some of the things that we need to think about as organizations here. So taking a washing machine and putting some kind of chip in it, and it becomes then a smart washing machine. And we can do lots of things with that. So now that I've got a smart device, I can then get diagnostics and information out of that device that I could then, as the vendor of that device, start thinking about new models for deploying it, for pricing it, and getting some market intelligence around how this device is used. And the obvious thing is maintenance and warranty. So how many loads of washing am I doing in this example? Can I have some kind of monitoring of the parts within my device? I can see when they're most likely to fail, when they need replacing. And the output of this really is some kind of quality improvement where if I see parts failing regularly, then I know there's a bug in my system and something needs to be replaced. But it all comes down to really this strong birthing process where sort of some kind of high-tech manufacturing system needs to be implemented so that we have reliable identities and code operations for these devices once they're deployed out into the field. So I said I wasn't going to talk about consumer devices, but the model works, I think, very well. It's kind of easy to understand, but this could just as easily be some part of critical infrastructure. It could be cars that we drive on a regular basis. It could be some kind of an industrial system or transport. But thinking of this kind of example then is, where might that data be used, and how might it be used against us? So, what is this market intelligence that's coming out here, and who owns that? So it's my device. I'm driving the tractor up and down my field, but the output of my device, or the spread of fertilizer and the yield that I gain through my device is somehow captured, through some smart system on my tractor. Do I own that as the farmer? Does the tractor vendor own that? How can they sell that on? So how might these models change the way that we interact with devices as we use them on a daily basis? And I think this is something really that we need to think about as when we work on these systems. If we are working on PKIs, for example, and this is a bit of a thing for me at Thales, is knowing that I might be working on a system that could be used in a way that doesn't really provide an advantage or a purpose, if you like, to the final end user. How could a system like this really benefit that farmer if it's going to be used to monetize the data that's coming out of it and get used to maybe holding to ransom to some degree, whereby I might say, well, I'm only going to tell you where the high yield areas of your farm are if you pay me a subscription fee. We don't want systems like that necessarily, but I think we'll start to see these kinds of things emerge. Transport systems, obviously, the same kinds of models. But again, always coming down to this strong credential where we can not only rely on ensuring that the data that's coming out of the device has some kind of integrity, but we can use that credential on the device as well to send information back to that device in terms of configuration updates, firmware updates. And I think this aligns with some of the agility that we've been speaking of as well, in that we need to worry about crypto and how to roll algorithms and implement new things on the server side, but how do we push that outward? The example a few years ago with Jeep, with the research that was done by Miller and Valacek, where they showed that you could compromise a Jeep and really get to that Jeep remotely across cell phone networks. They didn't have an ability to update the firmware on those cars to plug that hole. So they had to recall every single Jeep into a factory or into a dealership to upgrade the firmware to plug that hole. So we need to be agile at that side of things as well. And I think a lot of that really is dependent on a strongly birthed certificate where we can be assured not only is the device secure that we're talking to and it is genuine in that device, but that device can trust information coming back to it from the manufacturer. And then just thinking about kind of going forward and where we might see things changing. I've been talking about OEMs or up at the top of that manufacturing stack, cars or washing machines, but it's really better to get into this as low down in the supply chain as possible. Inject those keys into the silicon as part of the designs of these systems, rather than an afterthought when you're at the final product almost. Really providing some kind of a proof of provenance here, where that each chipset or each unit within your product has been securely manufactured and is a genuine part or a licensed part, perhaps. And so we talked about this a lot. It all comes down to trust. How can I trust that this is the device I'm speaking to? How can the device trust that it's being spoken to by the vendor or by a trusted party? And for me, this is all about cryptography, and then therefore a digital birth certificate injected in that final endpoint device. We've run some reports and do some surveys across different organizations as part of a study with the Ponemon Institute, where they survey out about 4,900 odd companies. And this was one of the statistics that we got back, whereby we believe, or they believe, in the next 2 years, an average of 43% of IoT devices will rely primarily on digital certificates. So, we've been talking about this a lot, but this is research that we're seeing out in the field where there will be a reliance on certificates and PKI in general to solve many of these problems. I don't really see many other ways that we can do this apart from using PKI. So what do we see then? Key security requirements for the IoT. Establishing trust between these entities is critical here. We need to have mutual authentication between the system out in the field and the back end. Validating the integrity of those systems. Have they been compromised in any way? Again, an example of the ASUS routers, where they came out of the factory badly configured, and you could get onto them and change that configuration and use them for different things. And then providing some kind of secure configuration for software or config updates. You need to have secure communications. And again, thinking about what kind of data might be coming out of there in line with things like GDPR. How can I make sure that the information this device is transmitting all over the place is secure and safe and isn't exposed in a way that could be compromised by attackers? And can we be assured that the data coming out of it is valid as well? Maybe back to the tractor example, from a good point of view is, I think John Deere is doing this, that as fertilizer is distributed through fields, there are sensors on the fertilizer distribution systems that measure how much fertilizer is distributed across a field. And this can be used then to prove to auditors in the European Union that you haven't over-fertilized your fields. You might be able to see it from the farmer's point of view again as to which areas of your field might need to be fertilized more. But if you can assert to the integrity of that data, you can then use it as within an auditing system and say, look, I have strong integrity or strong belief in the integrity of this data. You can be assured that it hasn't been tampered, because I can prove to you the system as to how this data was generated and harvested. Really allowing us some kind of non-repudiation from both the consumer and the consumer of this information. And then protection of data. I think we don't want to forget about the data. Whether it's in use, in transit, or in storage. So lots of data being used. Think about solutions like tokenization, maybe, where if we're doing big data analysis, do I actually need the identifiers of those citizens to do the analysis, or can I do it in a way that I still get the value out of that information, but I don't expose the risk so much there? And really, again, digital authentication here, I think, is the starting point for all of this. Strongly issued credentials into the devices so that we can validate their identities. And then, really allowing us to establish some kind of root of trust and the ability to then maintain a secure configuration of those devices. Just wanted to reiterate a point, though, is don't forget about the data. I think we think about things a lot from the front-end point of view and establishing this trust, sending information out, doing all of this configuration. But there will be a large amount of data coming back out of these devices, whether it's my step count, or whether it's the way that I use my washing machine, or whether it's light bulbs and critical infrastructure. Somewhere that data is coming back. And now with this kind of growing infrastructure of data becomes a big point of interest for attack. So we need to think about what kind of data we have and think about using encryption as a technology at the data side for protecting it. I think encryption has always been a bit of a worry for people. I think we heard yesterday about the big obvious point is if I lose my keys, I lose my data. So between us and our friends like Utimarco, we have better ways of managing those keys now. So think about a policy of encryption within your organizations across the entire board of all of your data. Not just in terms of regulation, but in terms of risk, really. Conduct risk analysis on the value of your data, the impact of what would happen to you as an organization in terms of losing that data, but what would the impact be to the consumers if their data was lost as well? But at the same time, kind of balance that against, if you can't read the data, if it is encrypted, how do you analyze it? And so you need to think about innovative or interesting ways of solving these problems. So I hope that's given you a bit of a snapshot into what we're doing, thinking about IoT in terms of device credentialing and managing systems once they're out in the field, getting data to and from the devices, but also giving you an insight into maybe how things might change in the way that we interact with those devices, but also, more worryingly, I think, how those devices might interact with us and how we might be monetized in some way. And so,
Thank you very much. Very nice wrap-up on IoT. In one way, I have a question. If I understood you correctly, so, well, I guess I did, but kind of as a word question as a comment. So if we do a good job in securing IoT devices, we are also allowing the end customers, corporations who are using those different type of IoT devices also to maybe augment or change their business model?
I think so. I think we'll start seeing more of this. And my worry is that I walk into a supermarket and I see one device again, a washing machine that's going to cost 200 euros, or I see another one that costs 100, but they have equal specifications. Why is one of them cheaper? And we might think about the implications of that and start thinking about, well, if I suddenly become the product here, like we all are products of things like Facebook and Twitter, we're not paying for it. So I'm concerned about that, but will the rest of the population be? And that's my biggest worry, I think, is if organizations do start monetizing our data, we need to be clear on how that's done. Does it? Yeah.
Thank you very much. Then we had a comment questions. Identities for devices do not necessarily make them legit for a given environment. An identity allows access control based on identity, for instance, whitelists.
Not sure I understood. Yeah.
We go to the original.
Oh dear.
Yeah, you answered the comment already in the sense that you mentioned earlier that we have a concern if the keys leak, then you suddenly have sort of someone is making bootleg machinery that looks legit. But one would hope that if, for example, in the case of a radio base station, for example, if you buy one from us and put it in your operator network, if someone else buys it from us and tries to put it in your network, I would hope that that won't work, even though it comes from us as a perfectly trusted source.
Exactly. And so I did my master thesis on this, was about adapting IoT controls to the credit card payment industry. And we've learned a lot of lessons here, and this is a perfect example. Is I buy a Verifone credit card terminal for a particular payment service provider. What if I get another Verifone terminal in from somebody else? Just because it's a valid Verifone terminal, how do I know that it is meant to be on my network? And so, yeah, whitelists, absolutely. But this is exactly how we manage terminal systems today. I'm not so in touch with mobile networks, but yes, we do need this. And I did mean to mention this earlier. I think that as Thales, and our HSM vendors, we think that the HSMs are the most important thing. And then, PrimeKey thinks that PKI is the most important thing, but there is so much more above that. There are all of these processes and procedures. And it's really that problem you're solving. Do you want to be a telco? Do you want to be a terminal vendor? Other things need to exist alongside it to make sure that it works in line with your business model.
Yeah, thanks.
Any hands? Yes. Excellent.
So I agree that PKI may be one of the core enablers of securing IoT through identities. One interesting paradigm. So we look at the algorithms available today to create hashes and signatures. And if we embed those in devices, maybe a plausible approach, probably the right approach. The challenge is we look at on the kind of incoming post-quantum challenges with being able to break those algorithms and those signatures. So as we commoditize or we provide solutions to industries, right, through signatures and things, what are your thoughts of how do we also, and I think quantum agility or crypto agility is one of the answers, but how do we do that for some of these legacy things? Legacy could be things that we deploy today or within the next year. And then within a few years, might have to get ripped and replace the identities. And the signatures may need to be replaced in the field, or it's throwaway. What are your thoughts in general?
Yeah, so I think that agility doesn't just come down to the algorithms that are used, but how we have access to those systems. So the Jeep example works, but the Dutch transport system, where I forget exactly how it happened, but the algorithms that were used for the MyFair Touch, the Dutch equivalent of the Oyster card, was compromised within days. And the result of that was that an engineer needed to visit every single turnstile, unbolt the sides of it, JTAG into the system or whatever, and update the algorithms or update the keys that were used for 10,000 turnstiles across the Netherlands, or whatever the scale was. But you can't be in that system. So you need to have the ability to remotely update, I think. If that's configuration or code or algorithm of choice or certificates or whatever. But that's part of your agility process, I think, is not just changing the algorithm, but being able to push it out to the endpoints. This is also the ASIS bit, right? So the configuration was bad from the factory, and I don't think there was the ability to push those out. Consumers had to initiate the upgrade themselves, and how many people actually do that?
Thank you very much. So the next, or at least a little applause.
Thank you, guys.